So anyway, brief history of it. Like I said, this is a very, very famous algorithm. So it was proposed in 1995 by Freund and Shepard. So again, the general idea is, in the beginning, the data, each data has equal weight, right? Then once we pick the first classifier, the one where it was making mistakes is increased, is given an increased weight, so that in the next classifier we pick addresses the mistakes of the first classifier, and so that's the intuitive idea. Through math, as you guys saw, how do we enhance it if we do e raised power? And based on this, we were able to also pick what should be the relative importance of the coefficient of that classifier, right? So anyway, this you guys have already seen. Yep. This is the same algorithm you've already seen. So now let's take a look at an example. Suppose we have 10 data items, okay? The way this data is written is, call this x1, x2, or 1, 2. So basically I went 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see, just like I showed you over here. Okay. This is a famous example on the internet, but they don't give you all the details. So basically what I did is I added all the numbers so that you can see how the whole thing is working. Okay. So anyway, what will be the weight of each one of these 10 samples? 1 over 10, 1 over 10, 1 over 10, right?
Initially, yeah.
Initially, okay. So now let's go to the next slide. Okay, let's pretend we picked our first classifier. And all it does is, on the left of it, if it is a blue, it's a correct classification. On the right, if it's a red, it's a correct classification, right? So how many are being incorrectly classified if our classifier is a linear classifier?
8 are incorrectly. 7 are
3. 3 are, see, because on the right is a blue, so blue is over here on the, sorry, my mistake, red on the right. Yeah, so to the right of this line, if it is red sample, it's correct. On the left, if it is blue, it is correct.
So right? There's 3 wrong.
So 3 wrong, which are circled over here. So what should we do to the weight of those 3? Increase them in the next round, right? And also we need to determine alpha for this classifier. Okay, so we already had the formula for alpha. We already had the formula how the weight should be increased, right? So you guys can later on verify this. I rounded it to nearest numbers so that it's easier to see. So which one were correctly classified? I remember our numbering was 1, 2, 3, 4, 5, 6, 7, 8.
So 3, 6, and 8 are
3, 6, and 8. Do you see 3, 6, and 8?
They have more weight.
Have more weight. And we want the sum to be always 1.
Yeah.
So the numbers over here are slightly off from if you do the exact calculation. And again, I made it such that it's easier to see. So if you add 3, 3, 7, 7, 7, it should be 42. So this became close to e to the alpha. Okay, and we also need to determine the alpha, right?
Of that one, yes.
Of the very first classifier. This, and again, according to, if I take you to the previous one.
Right there.
Alpha was this formula. E of m is the
number of
WE over W, which is essentially the sum of the weights of incorrectly classified, right? So in our case, how many were incorrectly classified?
3. 3
3.
over.
So it was 3 over 10. So this will be 3 over 10. So if we plug in, then I just rounded it to the little bit. So anyway, okay, so this will come to alpha of 0.42.
Yeah.
Okay. And this is the error in the first iteration, 110, 110, 110. So this was 0.3, right? Okay, so now the weights have become this. And now we pick another classifier. Let's pretend the next classifier we picked. And just to visually show you, because their weight was increased, visually we showed them a little bit bigger, right? Okay, now let's go to the second classifier. So now let's say the second classifier based on this given data, because now its job is to make sure, overall, but also these are handled as good as they can be. So let's pretend the classifier classified it like this. Once again, to the right is red, to the left is blue. So how many got incorrectly classified?
3.
What's their number? This is 1, 2, 3,
5,
4, 5, 6, 7.
4, 5, 7.
4, 5, 7. So do you see 4,
Yeah.
5, 7, right? So if we add them up, whatever 9 over 42 will be roughly 0.21. In the same way, if we plug it into the formula, we'll be able to calculate the alpha. So once we have the alpha, based on this alpha, we'll go and calculate what should be the weights. So what will happen to the weights of these 3?
Increased.
Increase, the rest will decrease. Okay.
And even still, because in the second iteration, there's some that are now right that were wrong previously. You know?
Yeah.
And that's
we only worry about over here. As we move forward, these will get increased weight. Everybody else
stays the same.
no, not stays. They actually go down.
Okay.
Okay. So the idea is relatively enhance it and relatively make the others, because we think those are not as important in picking the next classifier.
Sure.
And for the weight, it looks like each time it takes the error weight equal to the correct weight. Because here 33 over 66, it is half of the total weight. And the previous one was 21 over 42. Is it coincidence?
Okay, the error was 0.3, right? 110, 110, 110?
After updated, it is 27 over 42, so it will be 21 over 42. It looks like the weight here takes, the error is 3, takes.
Well, see, like, if I remember correctly, what I did is, I did apply that full formula over here for the alpha, for the e to the alpha, right? Okay, but then I wanted to make it an easy to understand distribution, so I then rounded it to the nearest numbers so that I could do.
The error rate here is 7 over 42. So the summation of them will be 21 over 42.
No, in this iteration, the error is based on this one.
After updated, 7 over 42, right?
Right, but that was by applying that formula before. Okay. So if we go back over here. Okay, so we determined the alpha, right? Which we came out to be 0.42 in that example. Then, based on this alpha, now we, sorry, not based on this alpha. Then we go and adjust the weight of each one of those. Whichever was correct, we multiply 1 minus e over em squared. So if it was incorrect, its weight will increase. If it was correct, its weight will decrease according to this. And then, like I said, then I further went and made it a normal expression, integer type of division because these numbers may come out 0.1555 or something, right? But when I did 3/42, I forgot the actual number is like 0.16. I mean, either way, you can do it exactly, or that was just to show you that always the sum is always 1. I don't know if I answered your question or not.
So we are like over time.
No?
It's okay. It is just as it is not like the sum of error is sum of correct.
Oh, you are saying the 7 over here, that I think was just by chance.
But it's repeated next time.
Is it repeating? Okay.
Professor?
Yes.
1236.
Oh, okay. All right. Okay, one more minute. So anyway, if you go through the rest of it, then what you will do is you'll end up with the 3 classifiers combined together with the weight alpha here, alpha here, alpha here. This was the first one, this was the 3rd classifier. If we put it on the real data, take a look, combined all 3, do they do 100% job or not?
100%?
Yeah. So next time I'll show you a practical application of this. Okay.